Hi everyone, welcome to MathWorld. This video is to discuss Cambridge International AS and A-Level Mathematics, Paper 4, which is Mechanics, for May-June 2023, and the code is 9709/41. Okay, so let's move on to question number 1. Question number 1. Two particles P and Q of masses m kilograms and 0.3 kilograms respectively are at rest at a smooth horizontal plane. So given two particles P and Q. Okay, so the MP is m kilograms and then the MQ is 0.3 kilograms. Now, at first they are at rest. Then P is projected at a speed of 5 meters per second directly towards Q. So the UP becomes 5 meters per second. And then now, remember, at first they are both at rest. So it means that UQ would be 0. Okay, this is before the collision. Now, after P and Q collide, P moves with speed of 2 meters per second in the same direction as it was originally moving. Now, find in terms of m the speed of Q after the collision. Means that after the collision, both are moving in the same direction. Okay, so Vp becomes 2, Vq is unknown. That is the question here. Find the speed of Q in terms of m. So now, from here, we need to refer to the conservation of linear momentum. Right? So, now according to the conservation of linear momentum, the momentum before the collision will be equals to momentum after the collision. This is after collision. This is before collision. Right? So the momentum is found using m times u. So the mass times the speed. So now I will get mp up plus mq uq equals to mp vp plus mq vq. So the mp is m, the up is 5, plus mq is 0.3, uq is 0, equals to mp again, it is m, vp is 2, plus mq will be 0.3, vq is the unknown that we need to calculate. So from here, the left hand side, it will be 5m because 0.3 times 0, it will be 0. Then for the right hand side, I will get 2m plus 0.3 vq. So from here, 0.3 vq equals to this 2m will be moved to the left hand side. It becomes 3m. So hence, your vq is 3m divided by 0.3, which is 10m. Alright, this is our vq, which means the speed of q equals to 10m. So this is the full solution of A. Okay, now after this collision, Q moves towards a third party, R, of mass 0.6 kilograms. So from here we know that, from the previous we know that the Q is moving towards the right hand side. So it will keep moving until, towards the particle R, which is at rest on the plane. Okay, so now this is Q, it is moving, and then this is R. The R is at rest, so UR is 0. Okay, then the MR equals to 0.6 kilograms. Right? So now, just now from the previous calculation, we know that the speed of Q is 10m. So now, I will write UQ here. UQ equals to 10m. Right? Then the MQ will be, MQ is 0.3 kilograms. Now, Q is brought to rest in the collision of R. So after the collision, this is before collision. Now after collision, the Q is at rest, okay? Q brought to rest means that it stops, not moving. This is a Q. So the VQ becomes 0. And then the R begins to move with a speed of 1.5 meter per second. So now the R will move. So this is VR equals to 1.5. This is after collision. Okay, now we need to find the value of m. So again, use the same principle, which is the conservation of linear momentum. We consider the momentum before and after the collision. So now I will get mq uq equals to a plus mr ur equals to mq vq plus mr vr. Okay, so mq is 0.3. The uq will be 10m according to the diagram here. So this is after the collision. Plus mr is 0.6, ur is 0. Then the mq is 0.3, vq is 0, plus mr is 0.6, vr is 1.5. So for the left hand side, 0.3 times 10m, it will be 3m. Then the second term will be 0 because multiplied by 0. Same for the first term of right hand side, 0.3 times 0, it will be 0. Then 0.6 times 1.5, it will be 0.9. So from here, your m is 0.9 divided by 3, which is 0.3. That is our m value. Okay, now question number 2. A particle P of mass 0.4 kilogram is projected vertically upwards from horizontal ground with speed 10 meter per second. Find the greatest height above the ground reached by P. Okay, let's say this is the P. Right, this is the ground. So it is projected upwards until, with the speed of 10 meter per second. Means that now here I will write Vp equals to, or because just involve one particle, I will just write U. So U equals to 10 meter per second. Okay, hang on please. Alright, so 10 meter per second. And then now you need to find the greatest height. So we know that when it reaches the greatest height, let's say here, okay, the V will be 0. It will stop a while. Right, I let the greatest height be S. So here is a S. Okay, so now from here, we need to get S. What is the S here? I will use V squared equals to U squared plus 2AS. Alright, this is a formula in the formula list. And now, your V squared will be 0 squared. U squared is 10 squared plus 2. The A is going to be negative 10 because it is against the gravity. Right? Then the S remains. So from here, I will get 0 equals to 100 minus 20S. Therefore, 20S is 100. Hence, your S is going to be 5. Alright, so this 5, since it is meter per second, it means this is 5 meters. So that's the greatest height. Alright, so done the 2A. Now move on to the next part. When P reaches the ground again, it bounces vertically upwards. At the first instance that it hits the ground, P loses 7.2 joule of energy. B. find the time between the first and second instance at which P hits the ground. Okay, so the diagram is like this. So initially, the P is drawn upwards, right? So let's say this is the maximum height. Then after that, it will move down and bounce. Hit the ground. This is the ground, right? Then it will bounce back. So now bounce back. So when bounce back, this is the first instant it hits the ground. Alright, after that, because now you need to find the time between the first and second instance when the P hits the ground, means that it will bounce back. So when you bounce back, let's say here, he will just reach the particle, or the P will just reach this height. Then hits the ground again. Right, this is the ground. Then bounce back. So this is the first instant it hits, and the second instant it hits. This is the second. This is the first. Now you need to find what is the time. Okay, so from here we know that initially the UA is 10 meter per second. Okay, we have found that the height is 5 meters. So this is 5 meters. Alright, so just now we know that M is 5, the S is 5. Now when it first hits the ground, here is the ground. Okay, it loses 7.2 joule. So just for information, since for the first motion, when it is moving up to the maximum height with speed of 10, when it hits the ground, the U here will be the same. Okay, the speed here will be the same. So but then since we need to get this first and second instance, I will let this be the U as well. So this U will be 10 as well. Okay, this U will be 10 meter per second because of the same distance. Alright, it moves up 5 meters, goes down also 5 meters. Therefore, it will be the same U. But then we know that when it hits the ground, it will bounce, but the height will be lower than the original height, the greatest height. So therefore, I let this be V1. Okay, so now the reason of the height for the first bounce is lower than the 5m here, lower than 5m, is because of 5 meters is because of loss of energy. Okay, so from here I will write initial KE, initial kinetic energy, equals to final kinetic energy plus loss of energy. Okay, according to the conservation of energy principle. So initial KE is the kinetic energy. It will be half mu squared. Alright, I write u squared first. Then for the final KE, it will be half mv squared plus loss of energy. So the loss of energy is given 7.2. Okay, so what is my half mu squared? So for this half mu squared, you need to consider this part when it first hits the ground. So it means that our u is going to be 10. So here I will write half. The m is just now. What is the m? M is 0.4. Okay, the m is 0.4. So the u is 10. So now becomes 10 squared equals to half m. We do know what is a v. That's why I write it be v1. Or probably you can just write v. So here is v. So I will write v squared plus 7.2. Now, Okay, so from this calculation, we need to find the v first. So from here, you will get half. Okay, my m, I have to replace the m by 0.4. So now from here, I will get 20 for the left hand side. Right hand side is going to be 0.2 v squared plus 7.2. So 0.2 v squared is 20 minus 7.2, which is 12.8. Then the v squared is going to be 12.2 divided by 0.2. Then you will get 64. Hence your v is going to be 8. So I know that it bounced back with 8 meters per second, no longer 10. Okay, so now I need to get the time between the first and second hits. So it means that it's over here. Right? So when it hits the first time, it bounces. After that, it hits the second time. I will say that the displacement will be 0 because we are considering at the instance it hits the ground. So for this case, I'm going to use another formula, s squared equals to, I'm going to use another formula which is s equals to ut plus half at squared because I consider the orange color now. Okay, so the displacement will be 0 because it hits the ground again, means that the displacement is 0. Then my u here will be my v, right? Because when you look at the whole picture, this is a whole picture, right, which is here, whole picture. So this v becomes our u, alright? So now I will write this as 8t plus half. The a will be the a will be negative 10, then t squared, alright? Because your v is moving up, so therefore your a will be negative 10. So then from here, you just need to solve the quadratic equation. Half times negative 10, it will be negative 5. Then you will be getting this quadratic equation. Then I can factorize a t. You will get 8 minus 5t times the t equals to 0. Then from here, my t equals to 0, or 8 minus 5t equals to 0. Hence, my t is going to be 8 over 5, which is 1.6. Okay, so when you look at the limits, the units here, it is meter per second. Alright, and it's impossible to accept t equals to 0 because that is the first and second instance. Right, the t must be more than 0. So this is omitted. And then I will get my t is going to be 1.6 seconds. So this will be the solution. Okay, now question number 3. A particle moves in a straight line starting from rest. The displacement as meter of the particle from a fixed point O on the line at time t seconds is given by this expression. Find the value of s when the particle is at rest again. Okay, is again at rest. So you should understand that when it is at rest again, that means the this is displacement. This means the velocity will be 0. Okay, so but of course, to find the s, you need to know the t because your s depends on t. So we are expected to get the t when the v equals to 0. So from here, you need to get the t. And then after you found the t, you find the s. Okay, these are the steps to solve this. These are the procedures to solve this question. So I will start with the s equals to t to the power 5 over 2 minus 15 over 4, t to the power 3 over 2 plus 6. So to get the v, right, to utilize this v equals to 0, to get the v from the s, we know that the v is ds dt. So we need to apply differentiation, which means this is going to be 5 over 2 t to the power 3 over 2. Because when we differentiate, we always minus 1 degree, right? If you still remember, differentiate x degree n, it will be nx n minus 1. So then, the second term, I will keep the minus 15 over 4. So to differentiate t to the power of 3 over 2, you now bring down the 3 over 2. Then t, the power of t now becomes 3 over 2 minus 1, which is half. And the last term without t means you are getting 0. So now I will simplify. It will be 5 over 2 t to the power of 3 over 2. 15 over 4 times 3 over 2, it will be 45 over 8 t to the power of half. And now because it is at rest again, means that I will let v equals to 0. Therefore, 5 over 2 t to the power of 3 over 2 minus 45 over 8 to the power of t half, it will be 0. Then from here, I will factorize the term. Let's say I factorize t to the power of half. Okay, you can factorize the fraction as well. So I will just leave it there. So t to the power of half, then I will get 5 over 2t minus 45 over 8 equals to 0. So when the multiplication of two terms equals to 0 means that one of them will be 0. I will write t to the power of half is 0. Or 5 over 2t minus 45 over 8 equals to 0. So when t to the power of half is 0 means that square root t is 0. Then the t will be 0 squared, which is 0 as well. So then it is not possible because we need to find it is at rest again. Alright, so which is not the starting value. Okay, so I will write here omitted. Then now 5 over 2t minus, this is equals to 45 over 8. I move the minus 45 over 8 to the right side. Then from here, your t is going to be 9 over 4. Alright, so I have found the t value when it is at rest again. But then the question asks for s. So just substitute this t into the s. Alright, so now when t equals to 9 over 4, the s is going to be 9 over 4 to the power of 5 over 2 minus 15 over 4 times by 9 over 4 to the power of 3 over 2, then plus 6. So when you calculate this value, it will be 15 over 16 meters. Right? So that's the s value. Okay, now question number 4. You are given the graph. So the velocity of the particle at time t after leaving fixed point O is v, meter per second. So this is the v. So this is a velocity time graph. The diagram shows a velocity time graph which models the motion of particles. The graph consists of 5 straight line segments. The particle accelerates to the speed of 0.9 meter per second. Here is a speed of 0.9 meter per second in the period of 3 seconds. Then travels at constant speed for 6 seconds. Constant speed, that's why horizontal line. Okay. And then comes instantaneously to rest 1 second later. So that's why we'll look at here, 1 second, the v becomes 0. So it is at rest. Now the particle then moves back and returns to rest at time t seconds. That's why, okay, because it returns, right? So it is a reverse direction. Therefore, you will get negative. The graph will be below the t-axis. Now find the distance traveled by the particle in the first 10 seconds of its motion. 10 seconds means that it's here, 0 to 10. So we know that, right, the distance is basically area under the curve. Okay, under the curve of Vt. Alright, so when you look at this graph now, obviously from 0 to 10, it is a trapezium. Okay, trapezium. And these two green lines are the parallel sides. So when you refer to the trapezium, right, let's say this is a trapezium, these two are parallel sides, and let this be A, this is B, the sides, and then the height is C. The area is going to be half bracket A plus B times C. So I know that this is going to be 6, okay, because 9 minus 3 is 6. And then the longest one will be 10. The height here is going to be 0.9. So then I will get half of 6 plus 10, then multiply with 0.9. That is our area of trapezium. This is half of 6 plus 10 multiplied with 0.9. Then I will get 7.2 meters. So that's the solution of A. Okay, now B, given that t equals to 12, find the minimum velocity of the particle. So when you look at the graph here, this is 12. Alright, so now we are requested to get the velocity. Remember, just now given the speed. Okay, so basically, let's say this is the particle. It moves until t equals to 10, then it comes to rest. So v equals to 0. When you look at the diagram here, okay, then now it will return. So moves back and return to O, to rest at O at time t seconds. So initially O, alright, which means this is t equals to 0. So after that comes to rest here, after that move back. Right? So now this becomes t equals to 12 seconds. So from here, since we need to find the velocity, right, I will use s equals to s now becomes the what is that? The displacements. Okay, so it will be half of the velocity. Let's say this is a minimum velocity times by the time. So look at here, right? So this is a time. Time and let be t. So now the s here, okay, when you look at here, the distance, one-way distance for the first 10 seconds, the total distance is 7.2 meters, which means here is 7.2 meters. When you go back, it will be same distance, 7.2. But then now, since we are looking for velocity. Velocity is vector. That means this s is basically our displacement. It's no longer distance. Okay, so 7.2 is positive because towards right side. So the s will be negative now because it is opposite direction. So now our s will be negative 7.2. Alright, because our s is a displacement, it's no longer distance. If distance, it will be 7.2. So now I will write negative 7.2 equals to half of the v is what we need to find. Then the t here is a time taken. So look at here, this is 10. When it reaches this point, it is 10 seconds. But when it goes back and reaches 0, the initial point, it is 12 seconds. Means that the time taken here will be just 2 seconds. Right? So if you want to do it step by step, it will be 12 minus 10. But it's actually 2 seconds. So from here, negative 7.2, it will be half of v minimum. 12 minus 2 will be 12 minus 10, it will be 2. So obviously the 2.5 can be cancelled off. Alright, so this can be cancelled off. That means your minimum velocity is negative 7.2 meter per second. Alright, so minimum velocity it will be negative 7.2 meter per second. So it is tally with the graph. Because when you look at the graph here, this part, you are finding this part. So it is the y-axis is v. That's why it is below the x-axis, right? So therefore, it will be negative. So another option is you can just use the area under the curve, right? So from here, we know that this is 2. Then you let this be the v minimum. Okay, so this is a triangle. So when you find the area of triangle, it will be a times b, half of a times b. Alright, so or another method is you can say distance equals to half of 12 minus 2 times the u velocity. Okay, then 7.2 is going to be u. So this u is a what is that called, the speed. Okay, so the u is speed. Therefore, minimum velocity is negative 7.2 meter per second. Okay, now part C, given instead the greater speed, this is speed, is 3 meter per second, find the value of t and hence find the average speed. So the first is value of t, the second is the average speed. Now, it's given the greater speed is 3 meter per second. Let's look at the graph. So from here, 0.9 is velocity, but then we can say that it is speed as well. Okay, so since you are given greater speed is 3, which means this is 3 now. Here is 3. Okay, when you consider the speed. So now, we need to find what is the t. What is this t? When the greater speed is 3. So which means now I will just use this triangle. Okay, or use back the same concept as in the B. So the distance is still the same, right? So I will write distance equals to half of speed, okay, u is speed, times the time. So now the time remains as t. Okay, the last hour, the last time is t, and then the previous time is at t equals to 10. So the distance here becomes t minus 10. So I will write t minus 10. Then now the distance is 7.2 because that is the journey back to the original point. Then now half, the greater speed is going to be 3. So here will be 10, t minus 10. And then I moved all these terms to the left side and keep the t minus 10. So I will write t minus 10 equals to 7.2. Now half times 3 is going to be 3 over 2. So when I move the 3 over 2 to the right side, it becomes times 2 over 3. So then my t is going to be, move the 10, negative 10 to the right side. So 10 plus this right side value. The right side value is basically 24 over 5. So at last my t is going to be 14.8 seconds. So done for the first part. Now second part is hence find the average speed. So we know that average speed is total distance over total time. Okay, total distance traveled. Right? So now from here we know that one way is 7.2. Okay, 7.2 meters one way. So since this is two ways, right? Back and you go there 7.2. Look at here 7.2 and go back also 7.2. So now our total distance here is going to be 7.2 plus 7.2 meters. Then the time taken, which is our capital T, 14.8 seconds. Therefore, it will be 14.4 over 14.8 meter per second. So at last, I will be getting 36 over 37 meter per second. So this is the average speed. Okay, so now question number 5. We are given this force diagram. So here consists of 4 forces. Now, 4 complanar forces at a point. The magnitudes of the forces are F newtons, 10, 50, and 40 newtons. The directions of the forces are shown in the diagram. A, given that the forces are in equilibrium. Equilibrium means that it will be balanced. Okay, find the value of F and theta. So let's look at the diagram here. Okay, so for the equilibrium cases, we need to consider the total forces upwards and vertically and horizontally. Okay, so for vertically, I will consider upwards as positive. So when you look at here, this can be not projected. This can be moved. Okay, so I can move this F upwards and this 40N upwards. So for your information, you are moving this F Newton upwards, right, vertically, but you are given the angle over here, which means you are not using the own angle, then we are going to use sine. Okay, same for the 40 Newton. You are given the other angle 60 degrees, but I'm going to move this 40 Newton upwards using this for 60 degrees. So it's not in its own angle. Therefore, I'm going to use sine. So now the vertical direction. Okay, for the vertical direction, the forces will be F sine theta plus 40 sine 60. Then it will be, because they are in the equilibrium, so the upwards will be same as the downwards force, equals to 50N. So that is my first equation. So I will get 40 sine 60 degrees plus F sine theta equals to 50. Okay, then from here I will simplify. 40 sine 60 is basically 20 square root 3 plus F sine theta equals to 50. Then from here I can get my F sine theta as a subject. So it will be 50 minus 20 square root 3. That is my first equation, because we need to find the F. Now, the second equation is you consider the horizontal force. I will consider the force to the right side as positive. So now, when I need to consider the horizontal force, means that I need to move down the Fn, right, so that it will be the same direction as the 10, and then I will move down the 40 Newton. Okay, so from here, when you look at this, I will get 10 Newton towards the right side, the F Newton together with the cos theta, because I move down this F using the theta, the angle theta towards the right side. And then it will be same as 40 Newton cos 60, because I'm moving down it using 60 degrees, its own angle. Alright, so then I will get my second equation, which is F cos theta plus 10 equals to 40 cos 60 degrees. So from here, F cos theta plus 10 equals to 40 cos 60 degrees is going to be 20. So now my F cos theta, it will be 20 minus 10, which is 10. So here I get two simultaneous equations. So to get the F and theta, right? So now I will use first equation over second equation. I will get F sine theta divided by F cos theta from the left hand side. Right hand side is going to be 50 minus 20 square root 3 over 10. So now for the left hand side, the F will be cancelled off. Then I will get sine theta over cos theta, which is tangent theta. So then 50 over 20 over 3, 20 square root 3 over 10, you will get 5 minus 2 square root 3. So we can cancel off all the 10s. Alright. So since your tangent theta is this value, then the theta is going to be 56.93 degrees, and then correct to one decimal place, it will be 56.93 degrees, and then final answer for the theta is going to be 56.9 degrees. So I find the theta first. Now to get the f, because you need to find the f, then I will refer to first or second equation. Definitely the second equation is simpler, so I will refer to second equation. So now from second equation, my f is going to be 10 divided by cos theta. So my theta, I will use 56.93 degrees. Okay, then from here you are getting 18.3 Newton. Or I will just write F. No need to write the Newton. So this is my F. Right? So now for B, given instead the F is 10 square root 2 and theta is 45. Find the direction and exact magnitude of the resultant force. Okay, so now I will use back the same expressions, which means I will use the vertical force and the horizontal force. So from this vertical and horizontal force, then we can find the resultant force. Then from there we decide what is the force and also the direction. So what I need to do here is, because we need to find the resultant force later on, so I will need to find what is the total force towards right side and upwards. Okay, so very simple, because just now I let it be upwards, means that for the total upwards diagram force, I will just move all this. Okay, move this 50 to the left hand side. Okay, then for the horizontal force, I will just move this 40 to the left hand side. That will be my force. So I will rewrite this and move the 50 to left hand side first. And I will let it be Fy. Okay, that is the total vertical force. So it will be 40 sine 60 degrees plus F sine theta minus 50. I get this from the previous working, this part. Okay, so for the total horizontal force, and towards the right side is considered positive, I just move the 40 cos 60 degrees to the left hand side and rewrite all the terms. Let it be Fx. Then it will be F cos theta plus 10 minus 40 cos 60 degrees. So now I will replace my F and theta accordingly. So here, 40 sine 60, no need to recalculate, because from the previous part, we know that 40 sine 60 degrees is 20 square root 3. So it will be 20 square root 3. Then now the F is 10 square root 2. Then sine 45 degrees minus 50. So then when you simplify this, it will be 20 square root 3 plus this second term is going to be 10 minus 50. Then I will get 20 square root 3 minus 40. Okay, then for the horizontal force, again now it is 10 square root 2 cos 45 degrees plus 10. Now this 40 cos 60, you can just copy from the previous part. So 40 cos 60 is basically 20 in the previous calculation. So I will write minus 20. Therefore, here is going to be 10, then plus 10 minus 20. I'm getting 0. Okay, so now you have to check. This Fy is positive or negative. Basically, when you calculate 20 root 3 minus 40, this is less than 0. Okay, it's a negative force. This is a total vertical force. It is negative. So I assume upwards as positive. So now you get negative, means that basically it is towards it is facing down. This is my Fy. So my Fy is basically 20 square root 3 minus 40. Okay, and then the Fx is 0, means that it is just it does not have the horizontal force. So from here I will just write resultant force, okay, R equals to Fy. So it will be 40 minus 20 square root 3 n. So that is the magnitude. Okay, you need to find the direction and exact magnitude. So I will say that since this is negative value, so it will be 20 minus, I will write it is 20 minus 30, 20 square root 3 minus 40. That is the magnitude. Alright, so I will write magnitude of R is going to be magnitude of 20 square root 3 minus 40, which is 40 minus 20 square root 3 Newton. Alright, so then the direction. So the direction is going to be pointing downwards. So pointing downwards, when you refer back to the original diagram, it is the same direction, it is in the same direction as the 50 newtons. So I will write here direction, same direction as 50 newtons. Okay, remember the magnitude is negative value. So to get the positive, the Fy is negative value. So to get the magnitude, it will be positive. That's why I just put the modular sign here and just swap, okay, these two values, that it becomes a magnitude already. Alright, so that's all for this question. Now question number 6. Two particles P and Q of masses 0.2 kilogram and 0.1 kilogram respectively, so you are given this diagram, are attached to the ends of a light inextensible string. The string passes over a smooth pulley at B, which is attached to two inclined planes. The P lies on the smooth plane AB, which incline at 60 degrees to the horizontal. The Q lies on the plane BC, which is inclined at angle theta degrees to the horizontal. The string is taut and the particles can move on lines of greater slope of the two planes. Right, this is the diagram. So now it is given that theta is 60. So theta is 60. I will let this be 60 degrees. The plane BC is rough and the coefficient of friction between Q and the plane BC is 0.7. The particles are released from rest. Determine whether the particles move. Okay, so the plane BC is rough. So from here we know that since the P is with greater mass 0.2 kg and the Q is 0.1, I will expect this P will move down. The Q will be moving up. Okay, with the acceleration of A, this is also A. And then here with string we have the tension. Here is also the tension. So now for the 0.2 kg, the mass, the weight, it will be 0.2 grams, 0.2 g, I would say g. And then now for the Q, going down, it will be 0.1 g. Okay, since I will expect the Q is moving up, means that the frictional force will be pointing downwards. This is the Fr. Fr is mu r. Okay, and then the frictional coefficient is given 0.7. That means this Fi is going to be 0.7 r. Then where is my r? My r is the normal force, which is here. Okay, so now this is my diagram. Determine whether the particles move. So you need to find what is the A. if you can get A value, that means the particles are moving. If the A equals to 0 means that the particles are not moving. So from here, I will find my R first. Okay, so when you look at the particle Q in this direction, which is same direction as the R, so this is a particle Q. Now my R is going to be, okay, so now you have to resolve. Okay, you have to resolve. Resolve the weight. This is the weight, 0.1 gram, 0.1 g, because the weight is mg. So I need to resolve this to the direction which is opposite to R. Okay, and then now the angle here is 60 degrees. So when I resolve the force, not using the own angle, I'm going to use sine. Wait, okay, when you look at here, this is 60 degrees. That means here is going to be 30 degrees. Right, here is 60. That means here is going to be 30 degrees because here is 90 degrees. Then now I need to get this angle. So again, this is 90 degrees. Right, here is 90 degrees. So I will get 60 degrees here as well. So it means that this region, this angle is going to be 60 degrees. So I resolve the 0.1 g to the, to using the 60 degrees so that it becomes the orange dotted line. So I will get 0.1 g cos 60 degrees. Okay, and then here is going to be 0.1 times 10 times half. At last, your R is 0.5. So then, now, when I consider the Newton's second law, F equals to ma, the point P. So I know that it is expected to move down because it's heavier. So it will be, I have to resolve this 0.2 g to this side, okay, which is along the plane. So again, the 60 degrees is over here, means that I'm going to use 60 degrees to resolve, then it will be sine. Alright, so it will be 0.2 g sine 60 degrees minus t equals to ma. M is 0.2, then a, let it be just a, because I will expect it is moving down. So the downwards force is greater than the tension. Now, from here, I will get 0.2 times 10. Sine 60 is square root 3 over 2. Then minus t equals to 0.2 a. Then now I will get square root 3 minus t is 0.2 a. This is my first equation. So same goes to the particle Q. Okay, so it will go down. It will go up because it's lighter. So I will get T. Then you have to minus a frictional force. Alright? So T minus the frictional force and minus the weight as well. So when I resolve the weight along the plane, so I resolve it here. Alright? I will not use the own angle, but I will use the 60 degrees over here, which means it is going to be sine as well, sine 60. So now for the points Q. So points Q, I will get T minus FR minus 0.1 G sine 60 degrees is going to be 0.1 A according to Newton's second law. So T minus FR is basically our mu R, 0.7 R. Okay, so my R already found, which is 0.5. So I will write 0.7 times 0.5. Then minus 0.1, G is 10, the gravity acceleration. Sine 60 degrees is square root 3 over 2. Then equals to 0.1 A. So from here, T minus 0.35 minus square root 3 over 2 is going to be 0.1 A. That is my second equation. So now the question says whether it is moving or not. They are moving or not. So I need to find my A. So it means that I need to eliminate the T. Okay, so since this is minus T and here is plus T, I will just add up two equations. So first plus second, I will get square root 3 from the first equation. Then the minus T and plus T will be cancelled off. Then copy all the terms on the left hand side from the second equation. Then for the right hand side, 0.2a plus 0.1a, I will get 0.3a. So from here, your A is going to be 1.72 meter per second squared. Since your A, since the A is greater than 0, therefore the particle moves. The particle moves. Okay, so there are two particles here. So this is how we solve this question A. Now, B, it is given instead the plane BC is smooth. The particles are released from rest and subsequent motion, the tension in the spring is this value. Find the magnitude of the acceleration of P and S is moved on the plane and the theta. Okay, now the BC is smooth means that we have to eliminate the FR. So no more FR over here. So no more R as well. Right? So this part will be cancelled. And then alright. Then from here we will just use back the same concept. The P is heavier, therefore it will go down, and then the Q will move up. Okay, so I will consider the equation from the for the points P now, the particle P now. So it will be similar to previous, which means this. Okay, I will copy back this and replace the T, the given T. Alright, so now I will write P 0.2 G sine 60 degrees minus T equals to 0.2 A. So the T is given, replace the T first, 0.2. Okay, this whole value, 0.2 G sine 60, actually no need to rewrite again because it's here. It will be square root 3. Alright, so now I will just write square root 3 minus the T is square root 3 minus 1. That equals to 0.2a. So from here, when you simplify the left hand side, I will get 1 equals to 0.2a. Therefore, my a is going to be 1 over 0.2, which is 5 meter per second squared. So the a done. Okay, the acceleration is done. Then now I need to find the theta. So then refer to the points Q. It is the same formula here, right? But then we have to ignore the FR. This one just cancel because now the plane is smooth. So I will copy T minus this equals to 0.1a. So I will get T minus 0.1 G sine theta equals to 0.1a. And then the T is given square root 3 minus 1 minus 0.1 G sine theta. Okay, so now the theta is unknown. Okay, so this theta is no longer 60. So I need to keep the term. So I will write 0.1, the G is 10, sine theta equals to 0.1, the A already found, which is 5. Then from here, you will get square root 3 minus 1, minus 0.1 times 10 is basically 1. So sine theta, that equals to 0.5. Then now my sine theta is going to be, just move the sine to the right side and this to the left side. So square root 3 minus 1 minus 0.5. Then it will be 0.23205 and your theta is inverse sine. So I will get 13.4 degrees. So that are the solutions for this question. Okay, now question 7. A car of mass 1,200 kg is traveling along a straight horizontal route the power of the car's engine is constant and equals to 16 kilowatt. There is a constant resistance to motion of magnitude 500 newtons. A. Find the acceleration of the car at the instant when its speed is 20 meters per second. Okay, let's say for example this is the car. Okay, so we know that the power is the P. Alright, P is 16 kilowatts. And then it has driving force, D. Alright, let D be driving force. And then don't forget, there is a constant resistance of 500. So since the D is moving right side, the resistance will be 500. So this is Fr. Alright, and then the mass M equals to 1200 kilograms. Find the A, acceleration, when the speed is 20. So the V equals to 20 meter per second. What is the A? So from here, I have assumed the D is driving force. Alright, so we know that power is driving force times the speed. So now from here, the power is given 16 K watts. The K means 10 times power 3. So the driving force is not given. The V is 20. Therefore, I know that the D is going to be, this is multiply. Okay, D times V. So D times 20. So my D is going to be 16,000 divided by 20, which is 800 newtons. So my driving force is 800 newtons. So from here, again, we are using the Newton's second law, F equals to ma, because the car will be moving to the right side, right? So A. So now, when you look at this diagram, okay, we have the D, we have the F, Fr here, and then we have the A. Means that now, I will assume the car is moving to the right side. Therefore, the force facing towards the right side is considered positive. So I will write here 800 minus 500, the D minus the Fr equals to ma. The m is 1200. Then the A is unknown. Okay, so from here I will get 300 equals to 1200 A. Therefore, my A is going to be 300 divided by 1200. At last, you'll be getting 1/4 meter per second squared. So that is our acceleration when the speed is 20 meter per second. Now, assuming that the power and the resistance forces remain unchanged, find the steady speed at which the car can travel. So you must understand that steady state speed means that no acceleration, constant speed. Okay, so use back the same formula. Power equals to driving force times the speed. So since the power and the resistance forces are remains, so from here I will get what is my speed first, because what is my D first, because we need to use back the Newton's second law formula. So now my P remains 16,000. Right, D is not given now because the speed is not given. So therefore, I need to get my driving force as 16,000 over the V. So again, I use F equals to ma. Now, the car is still moving to the right side. Okay, so use back this diagram. It will be D minus 500 equals to ma. So now, I will write 16,000 over V. This is my D minus 500. That is the resistance force, equals to M. M is 1200. The A is 0 here because it's mentioned steady speed. Right? So from here, 16,000 over V. Right hand side is 0. This minus 500 will be moved to the right hand side. It becomes 500. Then now my V is going to be 16,000 over 500, which is 32 meter per second. So that is my speed. that is my steady speed, equals to 32 meter per second. So that's why you must understand the steady speed means A equals to 0, constant speed. Okay, now the car comes to the bottom of straight hill of length 316 meters, inclined at an angle to the horizontal of arc sine 1/60. Okay, let's say here. The car is here, bottom. Right? The length of the hill is 316, so it means that the S is 316. Then the angle theta, whereby sine theta is 1/60, because you are given theta is inverse sine 60. The power remains at constant 16 kilowatt. So power is 16,000. But the magnitude of the resistance force is no longer constant and changes such that the work done against the resistance force in ascending hill is this. So this is the work done against the resistance force, equals to 128,400 joule. The time taken to ascend the hill is 15 seconds. So t equals to 15. Right? Given the car is traveling at speed 20, so u equals to 20 meter per second at the bottom of hill. Find its speed at the top. What is the v here? Alright, so from here we know that this car, the mass is 1,200 kilograms, so the weight is going to be 1,200 g. So from here I know that I need to count the work done by the engine first. So work done by the engine it will be power times time. Okay, so the power is 16,000. The time is 15 because it took 15 seconds to reach the top of the hill. So here is going to be 24, then all these 4 zeros, joule. Means that it is 240,000 joule. Okay, that is the work done by the engine. So total work done is going to be work done by the engine minus work done against the frictions, the resistance. Okay, against the resistance force. So I will just minus first 4 times of 0 minus 128,400. That is going to be 111,600 joule. Alright, so to solve this question, I need to refer to the work energy principle. So according to work energy principle, increase in mechanical energy same as total work done. Okay, so increase in mechanical energy is basically increase in kinetic energy plus increase in potential energy. So total work done is 111,600, which is here, the value that we have counted just now. Okay, so increase in KE is basically the final KE minus the initial KE. Alright, so final KE minus initial KE, initial kinetic energy, plus increase in potential energy, it will be final PE minus initial PE equals to 111,600. Okay, so now final KE, it will be half mv squared because I let the final V be, final speed is V, minus initial KE, it will be half mu squared. Okay, half mu squared, then plus this is mgh minus another mgh. So but then you have to remember, okay, final PE or initial PE at first here, the PE will be 0 because the height will be 0. So I will replace this by 0 first. Then equals to 111,600. Then now I will replace, when you look at here, I will replace the m. So it will be 1,200. The v is unknown, minus 1 over 2 times 1,200. Then the u is given. The u is 20. So I will get 20 squared. Plus the m is 1,200. The g is 10. The h, okay, so for the h, we need to resolve the s, the distance here. So when I resolve this, okay, vertically, right, that means it's going to be 316 sine theta because I'm using this angle. Okay, but then this angle is not given, therefore I use the other angle. So if I use the other angle to resolve, that means it's going to be sine. So I will write h equals to 316 sine theta. So I will get 316 sine theta. Okay, then equals to 111,600. Now remember, our sine theta is given 1 over 60. So then next step, I will replace the sine theta by 1 over 60. So here, when you simplify, you get 600 v squared. Then minus, the next value is going to be 240000. Then plus, here is going to be, okay, I will just write 12000 times 316. Then sine theta is 1 over 60. 111,600. So now we need to get the v. Alright, so I will get 600 v squared. Just move these two terms to the right side. So 111,600 plus 240000 minus 1200000 316 1 over 60. So now my v squared, or this whole value, is going to be 288,400. Okay, so now my v squared is the division of these two values. Then you will get 1442 over 3. So at last, your v is square root 1442 over 3 because we are finding speed. So I will just take positive value. Alright, so the questions ask for speed at the top. So you can just write here, speed at the top equals to 21.9 meter per second. Okay, so that's all for this video. Thanks for watching. Please subscribe to my channel if you like my video. Thank you. Bye.